Hi class, I wanted to make a quick video of a type of homework question you might run across involving an application of polynomial long division. This question says the area of a rectangle is 3x to the fourth power minus 9x cubed plus 7x squared minus 12x plus 4 square centimeters. It says if its length is x squared minus 3x plus 1 centimeters, find its width. So here we have to remember that the area of a rectangle is length times width. So that is something you always will have to remember when you're talking about a rectangle. So we have a scenario, pardon my artwork here, where we have the length given to us as x squared minus 3x plus 1. And a very common thing you want to do is always draw a picture and write down what you've been given and what you're looking for. They like us to find the width of this rectangle, so that's our unknown length. And in order to do that, I need to use the knowledge that I'm given, namely that the area is known to be this polynomial, this degree 4 polynomial. So if I'm given the area and I'm given the length, I should be able to solve for the width by simply dividing, right? So width equals area divided by length. So once I understand that, I am in good shape to do my polynomial long division. So let's take a look. We're going to take our original area, which was given to us as 3x to the fourth power minus 9x cubed plus 7x squared minus 12x plus 4, and divide that by the length, which is a trinomial. So we will need long division here. So let's do that long division here. We're taking 3x to the fourth minus 9x to the third plus 7x squared minus 12x plus 4. And watch me, because I am prone to error like you are when I'm going quickly. All right, so I'll be dividing that polynomial. If that's the area, I need to divide it by the length. And the length was given to us as x squared minus 3x plus 1. Now again, I'm setting up polynomial long division the way we typically teach it in the United States, which is to put what we're dividing into underneath and what we're dividing in out front. But if someone taught you in a different country, they typically do things reversed, and so that you might do it differently, and that's fine. So don't let me trip you up here. That is not my intent. So to begin the process, the way we do long division typically is we take our leading our leading term, and we say, what do I need to multiply that leading term by to get this leading term underneath? In other words, we're dividing 3x to the fourth by x squared. So we would need the coefficient, because it's a 1 right now, we would need it to be a 3, and we would need x to be squared, because x squared times x squared is x to the fourth. So I'm going to line that up into the appropriate x squared term below it. So that means I'm going to multiply by 3x squared here. And again, the algorithm says to multiply by the entire polynomial in front, which means to distribute it to all the terms in front. If I do that carefully, 3x squared times x squared gives me 3x to the fourth. 3x squared times negative 3x gives me a negative 9x cubed. And 3x squared times positive 1 gives me positive 3x squared. When you do long division, you always subtract at this next iteration of the algorithm here. So you can either just change all the signs, or you can put the negative in front of a parentheses, as long as you do in fact make each of them the opposite. So if this becomes negative, a positive and a negative, the same term cancel. If this becomes positive, we'd have negative 9x cubed plus 9x cubed. We weren't trying to cancel those out, but this time they do cancel. And if this becomes a negative, we have 7x squared minus 3x squared. So 7 minus 3 is positive 4x squared. At this point, we copy down our remaining terms. So negative 12x and positive 4. Sometimes you just copy down one term at a time. As long as you eventually bring them down, you'll get to the same place. Okay, so next up, we repeat the algorithm. So we're going to say our leading term x squared goes into this leading term 4x squared how many times? If you said positive 4, you were correct. So we're going to put a positive 4 here. And then I would repeat the algorithm by multiplying 4 times each of these terms of the polynomial in front. 4 times x squared is 4x squared. 4 times negative 3x is negative 12x. And 4 times 1 is positive 4. If you notice here, what we have is the exact same polynomial being subtracted here, because that's the next step, right? Long division is to subtract. Just like we did above here, we subtract. And since those are exactly the same polynomial, we end up with a remainder of 0, don't we? That becomes positive, that becomes negative, they cancel. So when you get a remainder of 0 here, what is that telling you with division? Well, it's telling you that this was in fact a factor. So this could have indeed gone into this polynomial with no remainder if I multiplied it by this polynomial. In other words, this times this equals that. Length times width equals area. So we've now found that the appropriate width should be 3x squared plus 4. Now how can you check that? And this is in centimeters, right? Since length was in centimeters, width is in centimeters, and you multiply, you get square units. You could of course check by multiplying and seeing if your area that you were originally given here does in fact equal your length, which you were given here, times your width, which is what we found here. So if I multiply this times this, do I get back to that? So you would have to check. In other words, you have to FOIL here, and you can know for sure. Well, I hope this was helpful in reviewing how to do polynomial long division from your previous math classes, but I also hope it was helpful in recognizing the importance of remembering formulas that model real-life phenomenon, for example, area of a rectangle, and how you can use that formula along with given information to solve for the unknowns. That's a very popular thing you'll have to do in any science and math class. I hope this was helpful, and if you have any questions, feel free to reach out to me. Otherwise, happy practicing, because math is not a spectator sport. I'll see you next time.